All right, so first of all, I think your exam schedule has been released by the registrar office. You can double check, but I'll show to you. For our class 2030, only one section there. It's going to be Thursday, August 14th at 9 a.m. for 3 hours. It's like a paper exam. I'll give you guys more information before the exam, but, sorry. There we go. Yeah, right here. Okay, you can double check as well. It's going to be 3 hours, and then I think maybe about the last class, I'll also give you guys some idea about the format, but it's going to be paper and pen. Sketch paper will be provided to you, and there'll be no data sheets allowed for the exam, so you have to know everything before writing the exam. Right, we'll talk more about it, but at least you know the dates. It's being confirmed by the registrar office. All right, so your priority now should be to complete lab number 4. It's going to be the focus for your final programming test, but you're going to have your written test number 2 first. It's going to be not this coming Friday. This coming Friday, we got the usual Q&A session there for the lab. You can drop by. The TA will be there to answer your questions. And your written test number 2 is going to be next Friday, July 25th, and we follow the usual pattern. I'm going to give you guys some guide about the coverage, and most likely will be something about inheritance today for sure, but I'll let you know the exact coverage. There will be some practice questions. I'll give it to you by Monday, and also there will be a review session there on Wednesday, most likely the afternoon, right? Like a usual time, in person. Okay. And let's see, yeah, lab number 4. That's really something you want to get busy with. That one's about inheritance. Okay. All right, any questions about the course? Yeah, again, my apologies for missing the class last Thursday, but I will gather together some makeup materials for you guys to really follow. I'll make it available to you, and that makeup material is going to be covered only in the exam, not in the coming test, so you don't need to worry. But I'll make it as early as possible so you can also take your time actually to study the material. I'll be in touch. All right, so let's now do a recap about last time, from last Tuesday. So today we're definitely going to dive deeper into the inheritance. Definitely today and also Thursday we're going to dive very deep into the inheritance, and then from there. All right. So last time we basically reviewed the first design attempt without inheritance. You just got to pay attention to about why we actually have some duplicates about the code, especially if you don't really have inheritance. You have to encode the kind of object you have, either resident students or non-resident students. Potentially, if you got more than 2 kinds of students, then this integer here may have different possible values. You want to really dive into this possibility here, right? I mean this design. It's going to violate single choice principle. To see exactly why, you can refer to the lecture recording. But that's really the if then else structure we have to keep repeating for every method. That's really the drawback for this design. And then that one there is just the third design that we talk about, right? Without inheritance. We just have to duplicate many codes over here that definitely violates the single choice principle, but it will satisfy this cohesion. So far we really talk about 3 different designs about either with inheritance or without inheritance. You really want to compare and contrast using the single choice principle and cohesion. That's something we talk about in detail in the class. So when you review for the written test, you definitely have to pay attention to them, and also for the exam as well. All right, and then so the not yet. Okay, so this one just to say, if you want to change certain parts about the policy, for example, you have to modify multiple places. So that's really a clear violation of the single choice principle. Whenever you want to make a change to your projects, you want to make sure it's a minimum number of places you should really modify, ideally just 1. If you have to modify multiple places, it's definitely a violation. All right, that's just another example there. You can do that as an exercise. And then, so this is just about if without inheritance, how can we create a student management system which is going to collect all kinds of students. Since right now we got resident students and non-resident students without inheritance, they're simply not related to each other. So we had to separate the array storage over here. So we got 2 separate arrays. So imagine that if you got 100 kinds of students, how many arrays do you need to have? 100 arrays. It's definitely a disadvantage, right? So that's another way for you to see the drawback for without inheritance. So we are really gradually moving towards why the inheritance is really a good idea, especially got OOP. It's really the choice to go if you want to program in large. All right, so that's the ultimate design that we have to know about inheritance, right? Very quick recap about what you should know. So number one, you have some inheritance hierarchy. You got some parent class, and also you got two subclasses or child classes. And the way to declare the inheritance relation is by using the extends keyword over here, right? So in a parent class, usually you're going to define everything that's going to be common among all the subclasses, something that's going to be inherited to both the resident students and also non-resident student. In that way, you can save as much as possible duplicates for your code. So that's how we satisfy the single choice principle. And now in the subclasses, right? So now think about what can you do in a subclass. Number one, you're going to inherit everything from your parents. Number one. Number two, you can choose to actually so-called overwrite the method that's inherited from your parents. For example, in the get tuition, in the resident students, you're first of all going to use the super keyword to really say, I want to reuse the version from my parents, first of all, to calculate the base amount. And then I'm going to change the definition also by using the premium rates. And similarly, you can do the same for non-resident students. So far we talked about you inherit everything from the parents, and also you may want to override or change something or redefine something from your parents. Number three, you can also declare new attributes and new methods in the subclasses. For example, let's say for the resident students, we have the new attributes that's only introduced at this level. It doesn't exist in parent class. Also, it doesn't exist in the sibling class, non-resident students. That's a new attribute here and also new methods. So this insight here, or observation, is actually very important because today we're going to talk about expectation and also think about when you actually compare child class and parent class, how do you compare the expectation, right? That's something I'll dive into as well. But you really want to make sure you revisit this particular hierarchy here to see exactly what the subclass can actually do, right? That's really important, okay? Guys, any question about this use of inheritance here? So you should definitely know how to use the extends keyword and also the super keyword. And when you use the super keyword, it can either be super dot, in which case you're calling some method from the parent class. And when you say super parenthesis, you're calling the constructor from the parent class. And you have seen this kind of syntax when we create the constructor for some exception class, right? That's similar syntax, all right? Yes? So basically, every time, well, as simple as this. In the context of the child class, whenever you say super, you go up exactly one level. You simply follow this extends keyword like an arrow and go to the student class. And then the super here takes a name, which is a string. And then you look for, among all the constructor in the student class, the parent class, look for the constructor that will take a string name. This is the only option, and that's it, right? By the way, some of your fellow students from the previous semester, they're wondering, can you actually use, for example, super.super.some method, which means I want to go up one level here, .super, and then another level up, .super. No, you cannot do it. Okay, super keyword in some way very constrained. You can only use it once in a single line. You can only use the super keyword to go to the immediate parent class. However, today, we're actually going to talk about in general, the inheritance hierarchy can have multi-layers. That's really something we want to study from today, right? Just keep that in mind. But I think for your lab number 4, I think just by studying this particular simple example very carefully is going to give you enough inspiration to really go for the lab number 4. And for your programming test number 3, it's going to be solely based on lab number 4. So you really want to pay attention to how things work and also how the inheritance is going to work, etc. Okay, we'll talk definitely more from today as well. Yes?
When you're using the word super
Good question. If you want to call, I believe when you want to call the super keyword as a constructor, like a parenthesis, right? It must be the first line, yes. However, if you're using the super dot, then it can appear, I believe, any line. I can double check, but I can double check as well. Yeah, so I think there's certain constraint, like an order in which you can use a super keyword. That's something you might run into in the lab as well. Yeah, it's some subtle rules. I can look into it. Maybe I'll talk about it a little bit later. Okay, yeah. I just don't quite remember exactly what it is. Yeah, good. All right. All right, guys. So just make sure you review this diagram, every once in a while. That's really going to help about clear. Okay. All right, and then programming inheritance. Yeah, you're going to declare everything that's common in the parent class, and also you're going to declare everything that's going to be unique to the subclasses, right? But today we're going to see multi-layer, right? So we'll see even more reaffirmation about this principle here. Right, this exercise here that we did last Tuesday, let me remind you, since being a week, is very important. Okay, so we talk about static type. So we declare 1, 2, and 3 variables, reference variables. The declare type, student versus resident student versus non-resident student. So these are the so-called static types. Static types simply determine the so-called expectation on that particular reference variable. What's really expectation? Let's say for S over here, if I say S dot, what method can I put afterwards, and then I can still make a compile? So that'll be part of the expectation. And what method can I actually call after RS dot, and I can still make the code compile? So when you talk about like a inheritance hierarchy, you will see that, let's see right away. I want you to compare this S over here and also this RS, right? These two variables. You can see we got S, RS. The static type is students versus resident students. It is student versus resident student. The expectation, as we figured out last time, for the students, the expectation is this particular range, right? For the resident students, the expectation will be wider right here. Typically, when you go low, the lower you get to the inheritance hierarchy, the more expectation you can have. Remember something we said before? What can you do in a subclass? One of them is you can introduce new attributes and new methods. That's why, intuitively, if you get down to some lower subclass, you should really get more expectation, right? That's some intuition you want to keep in mind. All right, so I'm not going to repeat exactly what I said last time, but just remember, for you to figure out the expectation for a particular reference variable, you want to look at the static type. It's a principle, we just have to make, just continue to use it, right, to solve the problems. Okay, and then polymorphism. So we talk about, let's say, S and RS. S has a static type students right here, and RS has a static type resident students right here. All right, we have these two. I'm going to make a clean page just to summarize. But what I want you to really make sure you understand is when we say S is assigned to RS versus RS is assigned S, just flip the order. Only one of them is going to compile. It turns out this is going to compile, but not this one here. All right? So let's that's kind of the last example we did, right? So what I need you to do when you study is review the kind of proof by contradiction that I spoke about. Even though I made it sound a little bit fancy, like proof by contradiction, but it's really the way for you to think about why one line should really compile, but the other one shouldn't. Right? If you look at the slides, it's also in the written form. Let me do one more explanation about this one here, and then we'll move on to today's material. All right? So let's now just remind us about this example here. So we have, let's say, students right here. And then we know that that one's a superclass, and we have a subclass right here. It's called resident students. And we have things like maybe name, and then courses, etc. So all of them will be inherited to resident students. And in the resident student, we can introduce new expectation. In this case, it will be premium rates and also set premium rate. So you can think about these two are intuitively new expectation that's introduced in the subclass. New expectation. Okay? And then let's now do the two decorations. So we say we got students S. Okay, let's say there's a new keyword to initialize the object, so it's not null. And also we got resident students. And then RS. Okay. So up to this point over here, what we have conceptually is something like this. We got S pointing to some objects. Also, we got RS pointing to some objects right here. Right? Of course, exactly what the dynamic type is depends on what's really omitted here, but it's not our concern at the moment. All right? So what we want to look at is a static type. So this is the static type for S. So this is the static type of S. And the resident student over here is a static type of RS. Static type of RS. And when you try to visualize what's going on in the code, sometimes it might be necessary for you to also put a static type aside. So for S over here, the static type is students. And for RS over here, the static type is resident students. So let's now think about what's happening here. We talk about expectation. Based on what we're saying here, since you got some new expectation in the subclass, so I can say something like the expectation of the resident students is strictly wider, or just larger than, strictly wider, because I know I got some new attributes there. Then the expectation of its parent class, which is students. Right? So when I say strictly larger than, for example, I got a premium rates and also set premium rates. Right? And then we say that this variable assignments. So after this, if I say S is assigned to RS, this is going to compile. Let's think about intuitively why. This is going to compile. All right, let's see why. What's going to happen is, if this compile, when we execute it at the runtime, S, rather than pointing to over here, is actually going to point to wherever RS is pointing to. Right? And then we say this variable assignment here is something called substitution, which we'll also talk about later in the slides. But I want to give you some preview, some intuitive preview. This is something called substitution. Substitution. More precisely, we are substituting whatever S is pointing to by whatever RS is pointing to. We are substituting what's being pointed to by S by something else, which is what is pointing to by RS. Okay, diagrammatically, let me just put these two aside, okay? So S over here is what's being pointed to by S, and also RS over here, what's being pointed to by RS, right? So we are doing this substitution. But the other way wouldn't work, which we explained last time. I'm just trying to talk about the other possibility. So why is this? S over here is expecting students. Now I'm substituting it by something which I know guarantee is going to satisfy RS. And I know that RS has more expectation to be fulfilled. In that case, whatever I would expect from S will be able to fulfill by RS. Okay, let me say that again. So now you want to really revisit this point again. So let's think about this, okay? So we'll say given that RS has wider expectation than S, because the resident students over here has wider expectation than student, as we said, right, from the inheritance hierarchy. Given that it is the case, by substituting S by RS. So substituting S just by RS, this particular object, guarantee this one here is going to fulfill whatever that's going to be expected by S. Was expected by S, guaranteed to be fulfilled. Right? So this is only the first time I'm talking about substitution. We're going to talk about it one more time when we actually got some more complicated scenario. But just try to maybe get some understanding from this. Right? It is very important. And an exercise for you would be, given this kind of logic here, think about why RS is assigned to S wouldn't compile. That's really something we said last time. Because RS is expecting something that's strictly larger than what S can offer. So you just cannot do the substitution. If you do it the other way around, you're going to run into trouble. So that's why it wouldn't compile. Right? So this is the very foundational rule that we're going to rely on when we talk about inheritance. All right? Any questions? If you got any confusion about any part, I don't mind repeating again because this is so important. Otherwise, we can move on. You can let me know later. Okay? So you still have time to digest. Okay. Okay, so let's now move on to the material for today. Well, so let's talk, first of all, something very quickly. Just about visualization. Okay? How do we visualize the objects? You have to look at the expectation. So look at the static type. So how do we somehow visualize the different objects over here? So here we got S, we got RS, we got NRS, right? In order to see what's really the box that we're going to create over here, you have to look at what's the new keyword over here, right? And the new keyword over here is the dynamic type. So new students, that tells us this should be student over here. And also you got new resident students, so that means you got resident student over here. And also you got, let's say, new non-resident students, and then you got non-resident student right here, right? So the title of the box tells you what's the object type. So that corresponds to the new keyword, okay? And what attributes should you really include? Over here, since we talk about student over here, so you should really include all the relevant attributes for the students, right? Let's say we got name, we got number of courses, we got registered courses. So these are from the parents. So these are from the parents. Students, objects. And then when you look at, let's say this one here, resident students, right? Resident student. That one there is going to be more like a superset. What it's going to include, first of all, everything from the parents will be inherited for sure. Right? You can see that's also the parents thing. Also, you look at the non-resident students, you also got the stuff inherited also from the parents right here. But you also got something additional. Let's say in the case of the resident students, right here, you also got premium rates. So this is the child-specific attributes. Child-specific attributes. And this one here as well. Depending on what the dynamic type is, you can see resident students got premium rate and non-resident student got discount rate, right? So when you visualize the object, just watch out exactly what attributes should be included in the box. So when you trace the code, you wouldn't get confused, okay? And of course, right now, you can see this setup over here. We still put the static type and dynamic type just be the same, for simplicity. But later on, we're going to see that when you got a static type, dynamic type, they might be different, subject to some rules. I'll make it very precise, either towards the end of today or maybe Thursday. Well, there's a rule of substitution that we have to be aware of, right? But here's just about visualization, okay? So having said this, you will see that on the slides, We also got some tester right here, just to show to you how you can trace the code. So you can see we got resident students, we got premium rates. We got non-resident students, we got discount rates. So I'm just going to highlight certain parts, and you can really try to do some tracing yourself. For example, you can see resident students, which is the dynamic type right here. That one there has the specific attribute premium rates. And also you got non-resident students, and that would be the non-resident student over here. And that one there has the discount rate. Right? You can also see the discount rate over here. And also you got premium rate right here. Right? And the rest, when you trace the code, it's going to be very similar. And I want you to also look at these two lines right here. When you see Jim.getTuition and also Jeremy.getTuition. Right? So Jim is this object right here. And Jeremy is this object right here. Right? If you try to trace it, you will see that Jim dynamically is pointing to resident students. Okay, so let me just say that. Dynamic type is resident students. And if you look at Jeremy, dynamic type is actually non-resident students. Dynamic type is non-resident student. That one tells you which version of the getTuition should be called. Depends on what the dynamic type is. If you look at, for example, Jim right here versus Jeremy. Because Jim has the dynamic type resident students, you know that the version of the getTuition using premium rates is going to be invoked for this getTuition. On the other hand, when you say Jeremy.getTuition, because Jeremy has the dynamic type non-resident students, you know that the version of getTuition that uses the discount rate is going to be called. Right? So this is something called dynamic binding, but I'll go over again in a clean page in a moment. But this page here, you can also trace by yourself. Okay? I'll write it down. So this getTuition is going to be the version from resident students. So this is going to be the version from resident students using premium rates. On the other hand, getTuition right here from Jeremy, because dynamic type is non-resident students. So the version from non-resident students using discount rate is going to be called. All right? Maybe on Thursday, maybe I can show you guys very quickly about this particular, like a different version. I can show it to you, maybe on Eclipse. I'll just need to set it up, maybe on Thursday. So that's something you can definitely use a breakpoint and debugger to verify what we talk about on paper. Okay. Okay, let's talk about this intuition dynamic binding. A little bit like a repetition right here, but I'll just do it a little bit cleaner. Okay. First of all, we have courses. We got 2030, right? You can see there's a course object right here. Okay, right here. And then we got resident student, we got non-resident student, right? So let's now try to trace the dynamic type at different timings. And then we're just going to, I think this is some exercise we did earlier when we talked about the equals method. But let's do it again, just to be sure that we understand it completely. Okay. So let's now try to draw the table right here. So I'm going to say 1, 2, and then 3, and then 4. Okay. So there are 4 different timings. Before we execute this variable assignment, I call it 1. After the first variable assignment, I call it 2. Before the second variable assignment, I call it 3. After the second variable assignment, I call it 4. All right? Somehow 2 and 3 are similar, but I'll just put them down anyway. Okay? And what we should do is, let's now draw a table. Okay, I'm going to put the variable just S. That's the one I'm interested because I want to see exactly which version of the getTuition is going to be called. So that's why I'm tracing just for S. That's the context objects. Of course, it's going to be impacted by the RS and NRS. So before that, you can see RS dynamically is a resident student. NRS dynamically is a non-resident student, right? So let me highlight it. So resident students right here. That's RS. Also, I got non-resident students right here, and then NRS. So these two objects are just kind of exist separately, okay? And I just declared this S over here, right here. So at the moment it's null, okay, in the beginning. So you can think about this student here is the static type. Static type of S, right? That's everything we have known, all right? And then what we're going to do is we're going to do two variable assignment. S equals RS and also S equals NRS. You want to go back to that intuition polymorphism page that we did last time to really see why S equals RS and S equals NRS. Why would they compile? That's something I will leave to you. Also, we talked about it also earlier today. Okay? Okay, and then we're going to talk about dynamic type. All right, let's now talk about the different timings. Number 1, number 2, number 3, and number 4. And just for completeness, we can also talk about static type. That one is pretty easy. Okay, static type. Let's sort out this static type colon here. The principle is static type never changes, right? So for this one here, I can write it out with complete confidence. This part here, static type for S never changes. Always stay to be just the students. That means once you declare a reference variable, its expectation never changes. Okay? But the objects that reference variable points to might change. Timing 1 here, we haven't assigned S to anything just yet, right? So the dynamic type is not unknown, just null, which I'll put, right? I'll just say null right here, okay? Of course, at this point, you shouldn't say S dot something. You shouldn't try to execute it. You got to get null pointer exception. All right, let's now take a look at number 2. So let's say we try to execute this variable assignment here. So that means S is now going to point to wherever RS is pointing to. In that way, S is now going to point to over here. So now what's the dynamic type for S? Resident students, right? You can see the diagram. So I'm going to put resident students. So after timing number 2, we will execute get tuition right away. So when we say S dot get tuition, which version of get tuition is going to be called? You have to look at, for the context object S, what's its dynamic type right now? Resident students. So that means the version from resident students using premium rate is going to be called. All right? So I'm going to say get tuition over here. The version from resident students is call. And this RS just corresponds to the dynamic type RS over here. All right? Dynamic binding simply means the version of the method that's going to be called corresponds to the dynamic type for the context objects. Okay? I'll write down just once more. Dynamic binding simply means the version of method invoked corresponds to the dynamic type of the context objects. So get tuition here, the version corresponds to the dynamic type for S at this point, which will be resident student. But as soon as we change the dynamic type for S, the story will be a little bit different. Okay, let's continue. Okay, so after this here, and let's say right before we try to execute S is assigned to NRS, dynamic type hasn't changed just yet, right? So that should remain the same. All right. And let's say we are now going to execute this line here. S is assigned NRS. What that means is S, rather than pointing to here, is now going to point to wherever NRS is pointing to, right? And that one there is going to effectively change the dynamic type for NRS to be non-resident students. Okay, so we can now try to fill out the table right away. So now at point number 4 is going to be NRS. That will be the dynamic type right now. And let's now try to recall the method get tuition. So if you look at this line here, S dot get tuition, you can see this line here and this line here are totally identical. But the dynamic type for S here and the dynamic type for S here are different. So different version will be called. Right? So this one here is going to call the version from NRS is called, which is going to use the discount rate. Okay? Yeah, I'll make sure I just execute this part to illustrate to you on Eclipse on Thursday. But try to look at this page on the paper first. Just make sure you understand what's going on. Okay? All right, any questions about this? Yes?
First of all, why did we start by saying that execution of part 1, the dynamic type is none?
No. Yeah. And, let me answer that first. Okay. So if you look at, okay, 1 here is right before this is executed. So before this very first variable assignment, you can see S was only declared. So that's why it has the default value null. When you the reference is null, there's no dynamic type.
Okay,
yeah.
My second question is, it said in the student class, the get tuition method is not there. Do we get a compilation error if we try to execute line 1? I mean, like,
I see what you mean. It's a very good question. So guys, I'm going to put a new page for your fellow student. It's a very good question. The question was, let's say the get tuition method does not exist right here. It only exists here and here. Is it going to compile? All right. Let me now start a new page. Very good question. I'll set it up in a slightly simplified way, and you will see exactly how to understand it. Let me now, first of all, put students here. And then we still have our resident students. And then we have non-resident students. Let's say, I'll explicitly say that the get tuition is not declared over here. Instead, it only exists at the subclass level. Let's say here, resident students, you actually got your here premium rates and also get tuition. And over here, you got your discount rate and also get tuition. So now, how many versions of get tuition do we have? Only 2. Right, rather than 3. So there's no base amount. You can think about as part of this get tuition, rather than calling super, we simply just using that loop, just duplicate the code. Right? Let's now consider the setup right here. If I say students, let's say S, like that, okay? And then if I say S will be, let's say, new. You know what? Let me not get there just yet. Okay. So let's say we got our resident students. RS will be the new resident students, whatever. And also we got our non-resident students. NRS will be the new NRS, right? Exactly the same setup. And then we say S is assigned to RS. After that, we try to call S.get tuition. Of course, you're going to put an insistent out of print line, for example, but let's omit that part. .get tuition. And I'm going to say S is reassigned to NRS. And then S.get tuition. Now, this fragment of code And here's a question. At the runtime, which version is going to be called right here? And at the runtime, which version is going to be called here? And let me tell you that this is a tricky question. Let's say this is set up, and my question is, at the runtime, which version is going to be called when we say s.getTuition for the first time? And what version of getTuition is going to be called for the second s.getTuition? What will be your response?
It will not compile.
There's no runtime?
No.
Are you sure about that?
Yeah.
How come?
Because S has a static type student. In that class, we don't have that method defined, so we can't have the reference. Dynamic type will only tell us which version we have to call.
That's
There
awesome.
is no-
Fantastic. All right. Your fellow students said exactly the right thing. So this code here does not even compile. Simply because if you look at this line here, for example, if you just look at this line here, this line is not going to compile because in order to see whether or not this getTuition is part of the expectation for S, what should we look at? Static type. Does S static type students consist of getTuition? No, not going to compile. All right? So here, I'm going to state it right here. So here, getTuition is not part of the expectation of the static type of S. Not going to compile. Answer your question? Okay, good. Before you throw another one to me, I don't mind. Okay, let me say some follow-up. So here, you might observe something very peculiar by the compiler. You might think compiler is not so intelligent. Let's look at this. Remember we talked about dynamic type, right? After this line here, what's really happening here? Let's say at this point, right? Right at this point. What we have is something like this, right? I'm going to make it very precise, and then I'm going to give you another look ahead of topic. So this one here basically is saying we got S pointing to dynamically a resident students. Resident student, right? Resident student objects. And that one, they must have the premium rates right here. And the static type for S is students. You might be thinking, why is the compiler not allowing this object to be invoked, getTuition, because it does have premium rates dynamically? Compiler, in some way, they wouldn't be able to figure out. They can only look at the static type for the declaration, which only includes the students, which does not have the getTuition method. As simple as that. If you, as a programmer, you're pretty sure at this point, S is really pointing to some objects that I can invoke getTuition on. There's one way to make it happen, something called typecasting. That's something we're also going to dive into, possibly Tuesday next week. All right? I'll write it down here. So this will be the exact motivating scenario for typecasting. Okay? So this will be typecast. May be necessary, may help. However, let me just tell you that as soon as we allow you to do typecast, you got to be very careful. Because even though typecast can somehow make things compile, but you might also run into something called typecast exception at the runtime. And there's also some systematic rule we have to follow as well. That'll be the topic for next week. Right? So that's why I say inheritance is a very challenging topic, but at the same time, you can see lots of scaffolding about how things work. So that's why just make sure over the weekend or between the lectures, make sure you catch up with the lectures, right, about how things work. We're going to build up gradually. All right, so this page over here basically just showed to you what if we don't really have to get tuition method on the students. In that way, this is not going to compile. And then I also give you some look ahead. If you somehow use typecasting, you can make it compile. But in general, whenever you use typecasting, you also got to watch out for a typecast exception. Okay, that's something we're going to talk about completely next week. I got another question, right? Go ahead.
Okay, so in the previous slides you mentioned that we can't do resident students equals to students because of the expectations of resident students being wider than students.
Mm-hmm.
I get that part, but I have an issue because if let's say you placed resident students equals to students, and then you said resident students don't get tuition, won't that compile?
So here, you cannot say RS is assigned to S. You just cannot. So over here, let's say given what we have declared over here, right? Let's look at the static type. Since we talk about compilation, you only look at the static type. So, so these are the three static types we have, right? So if you try to look, try to have this line here, when you say RS is assigned to S, it's not going to compile because S over here has the static type students. And RS over here has the static type RS, resident students. And this substitution is not allowed because if you do the substitution, what you expect on RS cannot be fulfilled by S. Right? For that one, I'm not going to repeat the argument. You can look at maybe the earlier part of the lecture. Right? So this is not going to compile. Right? So guys, you will see that basically we're just going to keep repeating about whether one direction of assignment should compile or why the other one should compile, right? You really got to make sure you can understand the intuition and see the rule. But I'll keep repeating, right? Think about it, and then we can clarify in the recap, maybe next time again. Okay, so, okay. Why don't we take a very short break? I do have something very quick to go over about visibility. We can do that after the break, and then we'll dive a little bit deeper into something else. Okay? All right, so before the break, we spoke about dynamic binding intuition. You can take a look. You really want to combine this with the polymorphism intuition slides, which just happened right before. Okay? Combine these two and see if you got any questions. You can definitely reach out to me if you need any assistance in understanding these. They're very fundamental. All right, so I want to talk about something very quick about visibility, like using public versus private versus protected. It's very straightforward topics, but it's really worth our attention just for 10 minutes or so. Before that, I want to write some notes for you. So far we talked about static type and dynamic type. So if you really want some like a good way to really see when should you use which to make to do problem solving. So there you go. Whenever you're making a decision about whether something will compile or not, something about compilation, you only look at static type. As simple as that. And if you want to look at runtime, behavior. So here, it could be something about which version of the method being called. Invoked. Another example, which will be also very important, would be whether or not certain exception will actually occur. Some exception will actually occur. Okay? In that way, you have to look at the dynamic type. Mainly. Sometimes you may need to look at the static type briefly to remind yourself, but I don't want to confuse you. Let's make it simple. You just want to think about compilation, static type, runtime, dynamic type. And I can mention the name just for now so you can have some idea, right before we talk about it next week. So exception here, The one we're gonna look at very carefully is something called class cast exception. One of them. So this will be some potential danger at the runtime that you got to watch out for when you do typecasting. At the runtime, you might run into class cast exception. But to really determine that, you mainly have to look at dynamic type. But you have to make some little bit reference to static type as well. But primarily, dynamic type. All right, so this page over here just tells you that's the principle you have to remember, right? If you want to memorize something, this will be something to memorize. That's it. Everything else will be logical, right? About expectation. All right, so before I move on, I want to talk about visibility very quickly, or modifiers, right? I'll give you some quick notes, and then we'll just do examples. And then you can see the slide just like a written form, which is more detailed. You can also look at them. And it's also on the lecture side, also make some example code available to you. I'll show you how you can use them in one moment. But let's summarize what you should know about modifiers. So modifiers in Java. And the modifiers basically defined about the visibility of either the class or the attributes, depending on what context you're talking about. It's going to define the visibility. Visibility meaning that how visible, for example, how visible is your attributes? Is your attribute only visible within the class, or is it within the package, or is it within the projects? Okay, we'll get there. So there are 4 modifiers in total. The most restrictive is private. And the second one there is called protected. And number 3 is when you have no modifier. Okay? Which means I simply don't put either private or protected, or the 4th one, which is public. So private is a keyword in Java, protected is also a keyword in Java, and public is also a keyword in Java. I'm pretty sure you have been using this and this. But for protected, you may also use it, but you want to know what the consequence is if you use it. I'm going to talk about it as well. Also, I'll give you some principle that you can follow. You can try to adapt that, maybe apply that in your lab number 4. So protected is really some consideration to make when you actually want to have inheritance for your projects, for example, lab number 4. So protected is something to do with inheritance. For example, your lab number 4. Okay? And these 4 modifiers can be applied to definitely attributes and methods. All these 4 can be applied to attributes or methods. Okay? And then these 2, either no modifier or you got public. So these 2 are the possible modifier for classes. You cannot use private or protected for class. All right? It's also mentioned in the slides. If you want to declare some modifier for attributes or methods, you can use all the 4 possibilities. If you only talk about the classes, you can only use these 2, just the rule. Okay? And let's now talk about, by using each modifier, what's going to be the consequence for the visibility, right? I'm going to talk about the visibility very quickly. It's very straightforward. It really not much to say. But how can you experiment with different visibility yourself? So what you can do is just go to the lecture site. I can show you very quickly. I believe I posted already. If not, I'll definitely do that after the class. So if you go to the lecture site, let's see. Under inheritance, codes. Okay, it's not there yet. Okay, I'll make sure I post it today. It's something called visibility example. I'll put it under the codes. I'll make sure I do that when I post the recording. Okay, but it's going to look something like this. I'll just show you how you're supposed to play with them. So when you import the projects into your Eclipse, you're going to see various projects over here. The font size is a little bit small, but I just want to show to you how you're supposed to look at that. So you got different possibility for the visibility for each project. For example, if you open one of them, okay, that one is about, for example, it reads like a package level attributes and methods. All right. So if you expand it over there, you will see that, for example, the methods and attribute we're declaring, they simply, okay, so we got cat, we got dog, and also we got furniture, right? For example, here you can see that for this integer over here in this class, we don't really say it's either private or public or protected. So it's simply no modifier, right? It's one of the possibility. If that's the case, if you're trying to refer to, for example, this particular attributes in another package, in that way, you will violate the rule. Because by declaring something that has no modifier, it's only visible within the same package, which should be furniture. But you're referring to it in another package is simply illegal, right? So that will be the kind of observation you have to make by looking at the example. So I set up everything for you over here. All you got to do is look at the comments and play with it yourself. Okay? Let's talk about the principles quickly. Okay? Let's talk about classes first. So there are only two possibilities. Either you can say public class, or you say class without a public. No other possibility. Okay? Let's say we got a project called collection of stuff, let's say. And we got three packages. We got a package for animal, package for furniture, package for shape. Under animal, we got cat and dog. Under furniture, we got chair and desk. Under the shape, we got circle and square, right? If I declare chair to be just a class without a public, that means I can only refer to this chair class within the same package right here. If I try to say I'm now in circle class, I try to declare a type chair. Can I do that? No, I cannot do it. All right. So for example, over here, in this class here, if I say chair and then C, is going to be a compilation error. Doesn't really matter. Even if you import the other package, doesn't matter because the visibility is going to be violated. On the other hand, if I declare the chair class as public, it's going to be visible throughout, across all the packages. In that way, if I try the same line inside the circle class, now if I say circle, and if I say chair, beg your pardon, chair right here, and then C, this will be okay, provided that I put an import statement, right? You can see the difference. Play with this kind of stuff, right, just to convince yourself. Okay, that's about the classes. That's it. And for attributes, you got four possibilities. Either you got private, you got no modifier, you got protected, or you got public. You got different visibility. You got some increasing level of visibility. Let's talk about them one by one. And I'm going to use this particular example here. Let's say inside the chair class right here, I have 1, 2, 3, 4 different attributes. And each one of them has different modifier, meaning that they got different visibility. I want to see what the consequence is for each modifier. Right? Let's now highlight them. And then your little task will be also look at the table here that also summarizes what I'm going to show to you. But I think visually I can show you something that might be a little bit easier to get an intuitive idea. Okay, let's look at one by one. Let's start with the most restrictive modifier. If I declare some W, some attribute W, private. Okay, so here I got W. You can see, okay, so W here. Oh, sorry, wrong color. W here, right? So W is going to be only visible within the class it is declared, just the chair class. So I'm just going to put W right here. That'll be it. You cannot refer to W outside the chair class. You cannot refer to it in the bubble chair because it's outside the class, right? Even though it's in the same package. Of course, you cannot refer to W inside the cat class either, right? Straightforward. Private simply means it's restricted to only that resident class for the variable. What if I have no modifier? If I have no modifier, that means that attribute is visible within that particular package. Okay? So that one there, I'm just going to show to you. So within that package. So that means for for X right here, it's going to be, first of all, it's inside the chair class, and also every other class in the same package, which will be bubble chair, also the desk. Right? So that one there would be X. Right? So far so good? Right? It's either within the same class or within the same package. And what about protected? Protected has to do with inheritance. You can think about in some ways like a package level plus something else. Okay? Let me write down the principle for you, and then we can look at that. Protected is basically two things, two parts. Number one, it's package level. Number two, any other subclasses for this particular class can also access this particular attributes, even though they might be in different package. Also, all the subclasses, which may or may not be in the same package. So how do we see that? Let's make the assumption. Let's say in the shape class, for whatever, in the shape package, for whatever reason, we got rocking chair extends the chair, right? So rocking chair is a subclass right here. So now, how visible is Y? The first part tells us Y should be visible to all the classes in the same package. So let's highlight that. So it's going to be here, it's going to be here, and then here. So this part here is going to be for Y, for the first part, package level. What about the subclasses? Because we know that the subclasses for chair includes just rocking chair at this point. So the rocking chair should also be able to access that. So just compare about these two. Package level versus protected, which will be package plus subclasses. Finally, the other extreme about public, just everything in the projects, basically, right? So in that way, you actually got over here Z. So everything in the project, either in the same package or not in the same package, doesn't really matter. So it's going to be every class in the projects, every one of them. Every one of them, and also every one of them. So that one would be for Z. Right, you can see we got all the four possibilities over here. And of course, we got these kind of facility from the language, like a Java, which one is to be used is completely up to you. Okay? So let's say you're trying to maybe design maybe attributes and classes for your lab number 4. What kind of attribute should you declare? Should you declare the attribute to be private or protected, for example? Rarely you should really declare attributes public. You don't want the attribute to be visible to everywhere else. You don't want to. For methods maybe, but not for attributes. So give you some idea here. Okay? Some principle just for attributes. Let's say you got some class called A, which is extended by class B. Okay, right here. Okay, A and B. Parent class and child class over here. Let's say you got A and B in your lab number 4. All right. You're not too sure. Let's say you want to declare, let's say, 10 attributes. You're not too sure which one should be private, which one should be protected, right? The way you can try will be, why don't you try to declare all the attributes to be private, first of all? Step number 1, declare all attributes to be private. And attributes that are private will not be inherited to the subclasses. So that means they will not be not inherited to subclass. Just do that as a step number one. Later on, you might find that there are certain attributes from here you do want to make them inherited to class B, in which case change from private into protected. Step number two, those attributes that should be inherited change to protected. Right? So that's a very simple workflow for you to follow, right? Sometimes you may not know when you actually need it, right? So you can definitely change that when you need to, right? A simple principle for you to follow, right? So that's about visibility, right? So we talk about 4 possibilities for the attributes and methods. You can play with them to see which one make more sense. But you would just have to know the rule about it. Any questions about this? We good? All right. We got about 10 minutes. I think we can do a little bit of introduction. Let's see here. Okay, let's do a little bit of introduction here. Okay, and then we'll dive in deep on Thursday. Okay, I'll just go directly to, let's see on the slides. It's about multi-layer inheritance hierarchy, right? So here we're just saying that you don't necessarily are restricted to only subclass, you're not restricted to parent class and also only 2 subclasses. Not necessarily in real life, you might have multi-layer, right? So here, once top parent class, you got 2 subclasses. For this subclass, you got another 2 subclasses, and etc. Okay? For example, under students, it can be either domestic or foreign. And for domestic student, it can be domestic resident or domestic non-resident. You know, just like as an example. So that'll be the example, but this one here, I'm not going to use as a running example, but the second one would be, what I want you to think about is could be some exam question I can ask you, okay? You want to think about, let's say, given this particular hierarchy, how can you implement it using the different designs that we spoke about, right? Design number 1 and number 2 are the ones without inheritance. Is it possible to really implement this many kinds of students using design 1 and number 2, right? Design number 1, if you remember, has something to do with the kind, right? And design number 2 has to do with many classes, right? Maybe you have to create 1, 2, 3, 4, 5, 6, 7, and you got lots of duplicate of code. Think about exactly how design number 1 and 2 can be put into place for this hierarchy here, right? That's only reflection of what I want you to think about. And design number 3, how can you build this particular inheritance hierarchy? So for every arrow you're seeing over here, so first you got to declare all 1, 2, 3, 4, 5, 6, 7 classes first. And then you will say domestic resident students extends domestic students. You're going to say domestic students extends students, etc. You're going to make sure every arrow is going to be reflected as an extends keyword. Okay? So all these questions there are important for you to think about. All right? And this will be the actual inheritance hierarchy we're going to use as a running example, like a smartphone example. I didn't really update the model. It's kind of outdated, you know, for each smartphone. Just bear with me for this semester here. But we're going to see. I want to go over with you about the different classes over here, and then about the different attributes and methods. Just get us familiar. So before Thursday, just make sure you go over this hierarchy here, make yourself familiar. We're going to refer to this multi-layer inheritance hierarchy very often, especially when we talk about typecast later. Okay, let's go over that. So we got smartphones over here. So at the top, we just got a general smartphone. Each smartphone has the 2 most basic features. We got dial and we got surf web. You should be able to call or receive, and also you should be able to surf the web, let's say. That's the 2 most basic features. What does that mean? That means every smartphone, it could be some iPhone, could be some Samsung, could be some Huawei, doesn't really matter. They must have dial and surf web. However, it might be different versions of the surf web. For example, maybe for iPhone, it's going to be Safari. For Samsung, it's going to be Firefox, for example, right? So every phone must support dial and surf web. That's so important, right? So this will be the basic feature inherited to all subclasses. Okay, that's very important here. And let's now go for different branches. You can think about this is one branch. This is another branch. All right? Think about this branch over here is about iOS smartphone. And this branch over here is about Android platform. We can think about it as more like a sub-hierarchy, right? Inside a big hierarchy, you may have sub-ones, sub-hierarchy. So when we talk about smartphone here, it can be either iOS or it can be Android. And for iOS, we definitely got surf web. We also got surf web over here. So you can think about here, surf web. Oh, make it smaller. We got surf web over here. And also we got surf web over here. But it's overridden, so different versions. Surf web for iOS is going to use Safari, and surf web for Android is going to use Firefox, right? It's overriding. And then you also have some new methods. Let's say for iOS, you got FaceTime. For Android, you got Skype. I'm not sure if you're using Skype. Maybe it's already outdated. But anyway, just for our purpose of illustration. So think about this one here is like a new method, FaceTime, that only exists for iOS. And also we got Skype that's only available to Android. Okay? And then under iOS, we got iPhone SE, iPhone 13 Pro. And for this phone here, we also got some new feature called Quick Take, let's say. Right? So Quick Take is only a new method that's introduced at this level only. And then under Android, we got Huawei or Samsung, right? So Samsung, we got some new method here called Side Sync. And also for Huawei, for this model specifically, we got something called Zoom Edge, right? Let's say that's the hierarchy we want to follow through for running example. So before Thursday, make sure you go over this diagram very carefully. All right? So I got about 4 minutes. Let's use it up, okay? What I want to go over with you is some important slides. And this is a slide I would like you to also go over by yourself. I'm going to visualize it on Thursday to begin with. But let's now go over that very quickly. Okay? So this might be the only time I'm going to just do slideshow and bullet point. I want to go over with you all the points, make some verbal remark, and then you want to go over the points yourself. And then we'll talk about it on Thursday. 3 minutes should be good. So recall what a type is. It simply means the range of runtime value you can take for a particular variable, right? It's a type. But when you talk about a type in the context of inheritance, it gets a little bit trickier, okay? So every class can be used as a type. It can be a class you declare in your projects, or it can be a class from a Java library, like an array list. So now we got inheritance. So we got a hierarchy, like a smartphone or for the student management system. Implicitly, the top of the hierarchy will be objects. Remember we said every class has their parent class as objects. So objects always at the top, implicitly. So if you look at this diagram over here, you can think about implicitly, we do have another top over here called objects. But typically, we don't really draw the object class into the context unless we want to talk about equals method or other object-specific method. Otherwise, normally we don't. It can just cause confusion. Okay, that's one thing. And then the extends keyword is the arrow. For example, you can see iPhone SE extends iOS. iOS extends smartphone. And then let's see next. Okay, extends, somehow a little bit, you may have seen this transitivity. What does that mean? Let's say this. Let's look at it here. I would say that iPhone SE extends iOS. iOS extends smartphone. I can also say implicitly iPhone SE extends from smartphone. Right? Similarly, I can say Huawei, whatever this model is, implicitly also extends smartphone because this class extends this class. This class extends this class. This class extends smartphone right here. So implicitly, I can say that Huawei, this model here, implicitly extends smartphone. Right? So here, extends is very important. When you visualize it, it's an arrow. Go all the way up to some hierarchy. That's something we're also going to dive very deep on Thursday. Okay, just 1 minute, and then I'll let you go. Okay, so every class implicitly extends an object class, right? Right, so this is something we have to go over very carefully. It's something called ancestor and also descendants, right? I'll just show you some very quick visual example. Ancestor simply means, let's say I have this class over here. Let's say Huawei right here. Let's use this as reference point. What does ancestor really mean? Ancestor is going to contain the class itself. And then all the classes, either it explicitly or implicitly extends, which will be Huawei. It explicitly extends Android. Implicitly, it will also extend smartphone. So we said 1, 2, 3 are the ancestors for Huawei. Ancestor. The other direction is something called descendants. Descendants means, again, let's use this as a reference point. The class itself is also its own descendants by definition. All the classes that either explicitly or implicitly extend this class will be called its descendants. For example, in this case, this class explicitly extends that, and this class explicitly extends that. So these three classes are the descendants of Huawei. One more example. What would be the descendants for Android according to that definition? How many classes are the descendants of Android? How many? Can you see that? The class itself, classes that explicitly extends Android, also all the classes implicitly extends that, which will be 1, 2, 3, 4 as well. So descendants will be 1, 2, 3, 4, 5, 6, 7. All right? It's a very quick visual preview. So before Thursday, I want you to look at this slide here very carefully, and then we'll dive deep into it. All right? I'll see you on Thursday.